All right, so the greatest integer function is going to force every output to be the lowest integer possible. Now, you can put any real number in there, a decimal, root 2, anything at all, anything that's crazy but real, but the output has to be an integer, and it's the lowest. So let's look at what this graph is going to look like. So what's going to happen here is we're going to start at the origin like we always do, 0, 0. And then look what happens here down here at the bottom. Let me zoom out. If I have an input of 0.5, which is like right here, say right here, put a little dot, 0.5 is going to be forced to have an output of the lowest integer. Y'all, what numbers is 0.5 in between whole numbers? 0 and 1. That's right. Which one's lowest?
0.
So the output is going to be 0. Which means every single little decimal right here is going to get rounded down to 0, excluding 1. Draw an open circle on 1. So what happens at 2? Positive integer 2 is going to actually start up here. Now remember, it's an open circle on the 2. Let's step up to 2 and draw a closed circle and open it up to the next integer. Let's look what happens here. So if I have an input of 2, here's where x equals 2. What's the lowest integer that 2 is close to? Right on the nose. It's right at 2. So if I have an x value of 2, look, I'm skipping over 1 because it's not bubbled in, but what is bubbled in? 2. Let's keep going and analyze this function. Here's -3. I don't have any graph for -3. Let's continue this pattern down here to the opposite side of the origin. I have a closed circle here, guys. Go right down here and draw a closed circle. In fact, let's draw closed circles all along this diagonal. I'm going to even continue where I left off on the right side. Let's just expand this graph as far as we can take it. Now remember, everything's getting rounded down. So all of these little steps have to have an open circle on the high side of the integer because everything gets forced down.
Is that a closed line?
Yes, lines are, yeah. These are graphed little steps. Graphed little baby horizontal lines. Remember, horizontal lines are constant numbers. All right, so let's take a look at where x equals -3. X equals -3 right here. And if we see, we actually touch the actual step function on -3. Now, honestly, those are kind of easy because they're like integers themselves. Watch this. Please write this down. So we're going to write an input. And the way I kind of draw this notation is I draw extra long brackets, and then I just put some parallel lines next to them. Let's look at pi. What does pi approximate to? Everybody knows it. What is it? 3 point what?
1/4.
Yes, positive. So let's kind of estimate where 3.14 is. Let's say it's like right here. If I try to go up and touch the function, oh, here's the function. What's the output? 3. Let's get crazy. Let's draw 5.9, and let's put a repeating bar above the 9. Like, it is not gonna get any closer to 6 than that. But look at what this step function shows you. Let's go to 5.9, which is almost on 6. We're gonna go up this line here. And where do you touch the graph, guys? Where does it touch? It touches right there, which belongs to, nope, 6 is open. What does it have to belong to? 5. Let me show you so I can erase it. Let's say this is 5.9 repeating along the x-axis. Here's your input. What bar do you touch? What little step do you touch here? 5. It always rounds down. It always rounds down. For everyone, for everything. Let's take another integer. Let's plug in, not an integer, let's plug in another decimal. Let's plug in a negative number. Let's plug in negative 6.8. Now listen carefully. What two integers is negative 6.8 in between? Negative 6 and negative 7. Which one's lowest? Negative 7. Let's check the graph. So let's say that negative 6.8 is like right here. What am I going to land on? Negative 7. Let's try another negative number because it's so fun. Now you can look at the graph or you can just remember what is negative 2.3 in between? What two integers? Negative 2 and negative 3. Which one's lowest? Negative 3 is the answer. That's right. That is how the greatest integer function works. And guys, all it does, to put in simple terms, it just always rounds down. That's all that it truly does.